Okay, so on the previous slide, you were supposed to evaluate these. So for the first one, you should have gotten, let me turn my pen on here, you should have gotten 14. And here you should have gotten 8. Now, the next one's a little different because it did not end. So when you have the square root of 14, you should get 3.7416573887. Now, I know I told you to round to the nearest hundredth or tenth, so you could have had 3.7 or 3.74 since all the numbers behind them are less than 5. All right, so I had you do these problems not only to practice your roots buttons, but also to show you the difference between rational numbers, which we know are numbers that can be written as a fraction. So since this is equal to 14, we can make this 14 over 1 rational. We can make this 8 over 1 rational. However, we can't do that with a decimal like this. So sometimes when you have square roots, you're going to get rational numbers. Everything we did before when we identified them in the last unit or the last lesson as rational because they equal a number, we can put it over 1. Here is where this is not rational. This is not a rational number because when you plug this in a calculator, this is a decimal. Does it repeat? No. Does it end? Well, some of you might be thinking, yeah, it ended at 7. It didn't end. Your screen ended. But when you have numbers that go on and on and on and on like this, they don't end. This is called a non-repeating. So non-repeating. So it doesn't repeat. And then it's also called a non-terminating, meaning it does not end. And remember, all rational decimals are repeating and terminating. So this ends up not rational. It's something we call irrational. Okay? This is now an irrational number, and that's what this whole lesson is about, irrational numbers. So you are going to go on to the next slide. You're going to watch a short video, and then we're going to come back and finish this lesson.